Hello everyone. Before we get started, I'd like to give a shout out to Math Elite for all his help and support for my channel. He makes great videos. I will include the link to his channel down below. Make sure to check it out. Now let's get started. So we have this inequality that we're going to prove for positive xyz values. The quantity x plus y plus z multiplied by the quantity 1 over x plus 1 over y plus 1 over z is greater than or equal to 9. So I'll be presenting two methods, so bear with me. This is going to be a little longer than normal. So the first method, obviously the more painful method will be introduced first. All right, so to do my first method, I'm going to be needing some inequalities. So let's go ahead and start by proving them first, and then I'll use them in my proof. Okay, the first inequality that I will need will involve the sum of the squares of three numbers compared to the sum of their two-way products. You know the two-way products from Vieta's formulas, but the sum of squares can also be derived very easily. So I'll start with the following. X minus y quantity squared plus x minus z quantity squared plus y minus z quantity squared. Now notice that all of these are non-negative expressions, so when I add them, the result is also going to be non-negative. Now if you go ahead and expand it, you're going to get x squared minus 2xy plus y squared plus x squared minus 2xz plus z squared plus y squared minus 2yz plus z squared, all greater than or equal to 0. So we started with something true and we'll end up with something that we're going to use. Okay, now notice that we can add x squared plus x squared. That's going to give me 2x squared. And then I get 2y squared, and then I get 2z squared. And then I get minus 2xy, minus 2xz, and then minus 2yz, all greater than or equal to 0. Now you can just go ahead and put everything that has a negative sign in front of it on the right-hand side, and then divide both sides by 2. So let me go ahead and show my work here, so I'm not skipping any steps. So you can just go ahead and add those quantities to both sides. And then you can just divide both sides by 2, and you're going to end up with the inequality that I was trying to get. Okay. So this is one of the inequalities that I'm going to be using, but not directly. I'm going to be getting another inequality from this one, and I'm going to name it number 1. And then by using number 1, I'm going to be getting another inequality, which I'm going to call number 2. And number 1 and number 2 will be used together to prove the inequality, our original inequality. All right, so let's see how this goes. Now look at the left-hand side. I do have the sum of squares. Now the goal is to make it a perfect square. So what should I be adding to both sides to make it a perfect square? The answer is what you have on the right-hand side, multiply by 2. So here's what I'm doing. I'm adding 2 times the quantity xy plus xz plus yz to both sides, and then that gives me 3 times that quantity because I already had that on the right hand side, right? Okay, now the left hand side becomes x plus y plus z quantity squared. This is actually the inequality that I was trying to get. Alrighty, cool. So this is going to be my number 1. Now using number 1, I'd like to get number 2. To get number 2, here's what I'm going to do. Now, first of all, at the beginning, we said that our inequality is true for xyz positive, and I always want to keep it that way. So let's suppose that xyz values are always positive. It's not always required, but I just want to keep it simple and always assume that xyz values are positive. And they can't even be 0 because notice that we have a xyz in the denominator, so they can't even be 0. So xyz are always positive, and if this is true, I can basically replace xyz with anything I want as long as they're also positive, right? So in this case, this is what I'm going to do. I'm going to replace x with xy, y with xz, and z with yz. You might be wondering why I'm doing this, right? But you'll see in a little bit. And it's going to give us another inequality, but let me go ahead and do the substitutions and simplifications. So I get xy plus xz plus yz, quantity squared greater than or equal to 3 times Now I'm going to replace x with xy, so it's going to give me xy times xz, because notice that this is x and this is y, right? And then plus xz, which is xy times yz. And then yz is going to be xz times yz. Okay? Now if you simplify this, you're going to notice that you're getting xy plus xz plus yz squared is greater or equal to 3 times x squared yz plus y squared xz plus z squared xy. And this can be factored. Let's go ahead and factor it. xy plus xz plus yz quantity squared is greater or equal to, now I can take out xyz, so this is how I can factor it, and this is going to be my second inequality, number 2. And notice that I got number 2 from number 1, so if number 1 is true, then number 2 is true. Okay, good. Now we have 2 inequalities. What are we going to do with them? Before we find out what we're going to do with them, let's go ahead and take a look at what we're supposed to show. Okay, so we need to show that for positive xyz, x plus y plus z, multiply by 1 over x plus 1 over y plus 1 over z is greater than or equal to 9. Now, since x, y, z are positive, I can just go ahead and, multiply both sides by something, so on and so forth. But let's just first make a common denominator. Here, if you make a common denominator, you get something like xy plus xz plus yz divided by x, y, z. So this is what I'm trying to prove, because both of these inequalities, imply each other. And if I can get to this, that'll be nice. So what do I have now? I have inequalities number 1 and number 2. And guess what I'm going to do? If you carefully look at the inequality that you have, you already see the x plus y plus z and xy plus xz plus yz on the left-hand side. And if you look at number 1 and number 2, you notice that we have the same expressions on the left-hand side, but they're squared. But that's okay. We can take care of that. So we're going to do multiply number 1 and number 2. And that's going to give us what we want. So let's see. The first inequality is my x plus y plus z squared. And then on the right hand side, I have the square. But what I'm going to do is I'm going to multiply the left hand side first. So the other term brings me xy plus xz plus yz squared. That's the left hand side. And what am I getting on the right hand side from multiplication? Notice that I have in one of them 3 times xy plus xz plus yz, and the other one has the 3 as well. So their product is going to be 9. Notice that this is number 1 and this is number 2. So their product is going to be 9 times xyz times the sum and the two-way products. Okay? So that's going to be 9xyz, and then I'll get the sum, which is x plus y plus z, and the sum of the two-way products, which is xy plus xz plus yz. Okay, so this is what I get from multiplying inequalities number 1 and number 2. Let's go ahead and simplify this. Since x plus y plus z are positive, because x, y, z are all positive, I can easily divide both sides by that. And I can also divide by this, because that's also a positive quantity. So all is good. So this gives us x plus y plus z times the quantity xy plus xz plus yz greater than or equal to 9xyz. So it's pretty close to what we're trying to get, but we still have xyz on the right hand side. Let's go ahead and divide both sides by xyz. Again, xyz are all positive, therefore we're allowed to divide both sides by that. Okay, let's go ahead and do it. Take this quantity, the product, and divide by xyz, and you're going to get that this is greater than or equal to 9. Now this is obviously what we got, but let's go ahead and turn it into the original equality. And the way we can do that is we can just go ahead and separate these terms here. Notice that if you divide xy by xyz, you're going to get 1 over z from there, and it's true for all the other expressions. So that's going to give you 1 over x plus 1 over y plus 1 over z. Multiply by x plus y plus z. This is going to be greater than or equal to 9. And second method basically involves another idea. So let me go ahead and write down the original inequality first. And you'll probably find the second method easier. Please let me know what you think, because I'm curious. So this is what I'm trying to show. I can't claim that this is true because I have to show it. But what I can do is I can actually work with the left-hand side. So I can just go ahead and distribute, multiply everything out and see what happens. But this is going to give me something interesting. So in order, before I go ahead and, just multiply everything out, let me go ahead and work on an inequality that I'm going to be using. So here's what it looks like. So I want to prove that x over y plus y over x is greater than or equal to 2. So need to show that this is true. How am I going to prove that? Easy. So I'm going to take this expression x over y plus y over x, and I'm going to subtract 2 from it. I don't know if it's going to be positive or negative. Let's just go ahead and simplify this. Now, if I make a common denominator, I should be getting multiply by x, x squared, multiply by y, y squared, multiply by xy, minus 2xy divided by xy. Now, notice that the numerator is x minus y quantity squared, and the denominator is, of course, xy. Now, since we know that x and y are both positive, x minus y, and in this case, obviously, you can assume that x and y are different, but even if x and y are the same, this is going to be true because x minus y squared is non-negative. So in other words, this quantity is always greater than or equal to 0. Why? You're dividing something non-negative by something positive. Great. So what is that supposed to tell us? Well, it means that x over y plus y over x minus 2 is always greater or equal to 0, and this implies that x over y plus y over x is always greater than or equal to 2. So this means that if you add a number, a positive number, to its reciprocal, the result is always going to be greater than or equal to 2. And you can check this, right? Obviously. So now this is the inequality that I'd like to use, but before I use that, let me go ahead and distribute everything here. So if I distribute x plus y plus z over that, this is what I'm getting. I get x times 1 over x, which is 1, and then I get x over y, and then I get x over z. And then I distribute to y, I get y over x, and then I get y over y, which is 1, and then I get y over z. And then I distribute to z, I get z over x, and then I get z over y, and then I get z over z, which is 1. Now, notice that I'm not assuming anything here. I'm just going to put this together. So I get 3 plus x over y plus y over x. Let's go ahead and arrange the terms that way. Plus x over z plus z over x plus I have the y over x plus, oops, I'm writing the same thing again. I use xy, xz, and yz. So y over z plus z over y. Now notice that I have a constant 3, but this expression is known to be greater than or equal to 2 from this inequality that I just proved. This expression is pretty much the same thing. You just make replacements. This is greater than or equal to 2, and this is also greater than or equal to 2. Notice that I have 3 quantities that are greater than or equal to 2, and I'm adding 3 to them. So in other words, I can safely say that this expression is going to be greater than or equal to 9. So that means this inequality is greater than or equal to, this expression is greater than or equal to 9, which means this is greater than or equal to 9, which means that my original, because everything can be reversed here, in other words, this means that my original inequality, which brought this to us, this expression right here, because it gave this to us, right, when after we distributed, and it happens to be greater or equal to 9, this inequality needs to be greater than or equal to 9. And this concludes the second method. And this brings us to the end of this video. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.